Good afternoon, class. Today we're going to be doing some work with right triangles. So, here I have a right triangle, and we can tell that this is a right triangle because two sides come together to form a right angle, and we have a third side opposite that right angle called our hypotenuse. So, our formula for whenever we have a right triangle to find any one side of the right triangle, if we have the other two sides, is a squared plus b squared equals c squared. So, now it says right triangles and not right triangles, and we have a bunch of triangles down here. So what we're going to do is we're going to sort these into right triangles and not right triangles. So this triangle, we have three sides, so it's a triangle, but we do not have two sides coming together to form a right angle. We do not have any square in one of our corners, so I'm going to say that that is a not right triangle. And I think we can see the same thing with this triangle. We have three sides, but no right angle, not a right triangle. So, how about these two? Well, we have three sides, but we do have a right angle, so that is a right triangle. And then this one, we have three sides and a right angle. It is a right triangle. So, now we have four different boxes, and one says right, one says isosceles, one says right and isosceles, and one says neither. Now, we have a bunch of different triangles down here, so let's go ahead and group them. So, down here, we have two sides that are congruent. Now, if we remember what we discussed when we were discussing isosceles triangles, we know that two sides being congruent makes it an isosceles triangle. And we have two sides coming together to form a right triangle, so we're going to call that one right and isosceles. Now, down here, we have three sides, so they are triangles, but we don't have any congruent sides. We don't have any right angles. So I'm going to call that neither. That's neither a right triangle nor an isosceles triangle. So here, we have three sides. There is a right angle, but I don't see any congruent sides. So I'm going to call that just right triangles. And then the last ones, so we have two congruent sides, but we do not have any right angles. So I'm going to call that just isosceles triangles. So now we need to group some triangle classifications into real triangle classifications and not real triangle classifications. So isosceles, well, we just did some work with that, so I'm going to call that a real triangle classification. Right triangles, we've been working with those, so I'm going to call that a real triangle classification. Equilateral. Now, if we remember, equilateral triangles are the ones with three equal sides, so we're going to call that a real triangle classification. Right and isosceles, well, we just saw some of those on the previous slide, so I think those are real. Now, right and equilateral. Now, here's the thing, is that right triangles, we have a squared plus b squared equals c squared, right? Now, in order for it to be an equilateral triangle, we need all three sides to be congruent. But one side is equal to the sum of the squares of the other two sides. So I'm going to say that we cannot have a right triangle, which is also an equilateral triangle, and going to put it in a not real triangle classifications. So, in a right triangle, the hypotenuse is easy to find. It is the side whose lengths measure, I wonder, maybe if we erase here, ooh, well, there's some text, the sum of the squares of the other two sides. That's good information. So, here's an example of a right triangle. Well, where is it? I see an orange block and I see nothing. I wonder what happens if we, oh, there it is. So there's a three-sided triangle with the right angle, with two sides coming together to form a right angle. So that is a right triangle. Now we have a magnifying glass. So, I wonder what we can do with the magnifying glass. Well, it says use the magnifying glass to reveal more information about the a squared plus b squared equals c squared theorem. Okay, well, what if I move this magnifying glass? The formula for a right triangle is also known as the Pythagorean theorem. That's neat. When using the Pythagorean theorem, it doesn't matter if we move, rotate, or enlarge the right triangle, the theorem will still work. Move these triangles to see why. Okay, well, I can't move this one left to right, but I can move it up and down. And notice that it still stays the same right triangle. So I'm going to say that that does work. That is still going to follow the Pythagorean theorem. So how about this one? I can't move this one up and down, but I can move it left and right. So we see this stays as the same right triangle, so therefore the theorem will still work. Now how about this one? Oh, it spins. But it stays the same right triangle as we spin it. So I'm going to say that still works. So for more information on Pythagorean theorem, click this triangle. Well, okay. Ooh, an entire information page about the Pythagorean theorem. So I'm going to go ahead and split this screen. And then for more information on Pythagoras, click this picture of him. Well, there's an entire biography on Pythagoras. Pythagoras was truly one of the greatest thinkers and mathematicians of his time. Indeed. For a reminder of the Pythagorean theorem, pull the tab. Well, okay. A squared plus b squared equals c squared. Several chess pieces create right triangles with their movement, including the knight and rook. Well, what does this mean? Well, how about if we think about how the knight moves? So the knight moves by going 2 down and then 1 over. So if I move 2 down and 1 over, and then I connect the two sides, well, these two sides form a right angle. I think that's a right triangle. And then the rook can move straight down, and then it can move straight over. Well, how about that? Straight down, straight over, connect the two sides. Right there's a right angle. That's a right triangle. So, how about these problems? Okay, so what if we just focus on this problem for right now? So we have 6 and 8 as our two side lengths, and x as our hypotenuse. So what can we do? So we can put 6 squared plus 8 squared equals x squared. So that's 36 plus 64 equals x squared. X squared equals 100. X equals 10. So we just found our hypotenuse length because we knew the two other sides' lengths. Okay, so let's go ahead and try these two. So starting with this one, we have 12 as a hypotenuse, 8 as a side, and y as a side. So what if I did 8 squared plus y squared equals 12 squared? Let's go ahead and have you guys solve this one.